In this video, we are going to discuss problem based on the special case of circular motion, that is a vertical circle. Problem 9.1 says, perhaps the biggest thrill to be had at an amusement park is on a roller coaster with a vertical loop in it, where passengers feel almost weightless at the top of the loop. The problem is asking us, suppose the vertical loop has a radius of 5 meters. What does the linear speed of the roller coaster has to be at the top for the passengers to feel weightless? Assume that friction between roller coaster and the rails can be neglected. So let's sketch the problem where we have a vertical loop and the radius of the slope is given to be 5 meters. We need to find what should be the linear speed at the top of the loop for the passengers to feel weightless. Now, vertical circle is different from uniform circular motion because here the value of linear velocity is different for different points on the circle. Whatever linear speed you have at the top will not be the same as the linear speed at the bottom due to the effect of force due to gravity. If we need to find what should be the linear speed at the top to make the passenger feel weightless, we need to first find what are the forces acting on the passengers on the top here. So let's draw the free body diagram. The first force that we will draw is the force due to gravity, which always acts vertically down. I will call this Fg. And since the passengers are on a seat, the seat will exert a force of normal perpendicular to the surface on the passenger. So we draw the normal force and call it N. Both the force due to gravity and normal force are acting towards the center of the circle. And these are the forces that will provide the required centripetal force to keep the passengers along the circular path. So I will write my centripetal force Fc to be equal to force due to gravity plus the normal reaction force. Now let's discuss what is weightlessness. Weight of an object is the force due to gravity acting on an object. And you can only feel this weight if there is a reaction force acting on you. So if you're lying on a surface, if you're standing on a surface, the surface exerts a normal reaction force on you. And because of this normal reaction force, we feel our weight. This normal force always acts perpendicular to the surface. Now, any object will feel weightless in absence of this normal force. If there was no reaction force acting on you, you will not feel your weight. So if we want the passengers to feel weightless on the top of the circle, the normal force acting on the passengers must be equal to 0. And this is what we are going to substitute for our equation here. For weightlessness, we will substitute the normal force acting on the passengers to be 0. So I get my centripetal force Fc to be equal to force due to gravity. Centripetal force is given as mass times centripetal acceleration, and force due to gravity will be mass times acceleration due to gravity. I can cancel off the mass here from both sides, and then we write centripetal acceleration equals g. Centripetal acceleration I can write in terms of linear speed as v squared over r. Since we are finding linear speed, I will write AC in terms of linear speed equals g. Now you can use shift solve here to solve your problem by substituting all the values and solve for v. Or we will rearrange the terms to write in terms of v. So let's multiply with r on both sides to get rid of the r here. We get v squared equals r times g. Take square root, v will be equal to square root rg. Now substitute the value. R is 5 meter, g is 9.81. And when you solve this, you get your linear speed as 7 meter per second. So this is the linear speed the passengers must have on the top of the roller coaster for them to feel weightless.